Right, guys, today we're going to do Unit 12, Section 6, talking about segment relationships in circles. Our objectives are to find the lengths of segments formed by lines that intersect circles. Use the lengths of segments in circles to solve problems. Okay. We've got our theorem here, chord-chord product theorem. All right, if two chords intersect in the interior of a circle, remember a chord is where the endpoints are on the side of the circle, then the products of the lengths of the segments of the chords are equal. Okay, so we have chord AB and we have chord CD. So what that says is that segment AE times segment EB is congruent to CE and ED. Alright, so let's see what we have here. Find the value of X and the lengths of each chord. Okay, so we have chord that's GH, which is 14 and X. So if we take 14 and times X, we can put that equal to, we have a chord FE, 7 times 10. And then let's simplify. Solve for X. Okay, so here's our first value. Solve for X. Find the length of each chord. So we have chord GH, which is 14 plus X. Well, if X is 5, that value is 19. And then we have chord FE, which is 7 plus 10. And that value is 17. Okay, I'm going to be quiet and let you do this one on your own. If you get stuck, you can look up here at the smartboard. There's your 3 answers. All right, moving along here. I'm going to let you read this on your own, silently. Okay. So what I have here is I have this chord, and then I have this diameter. Okay, so what I have here, because these segments here are congruent because of these marks, I can say that this is 9 and this is 9. And then this segment right here that extends down, I can say is the diameter minus 8, because this is your diameter, and if we minus this 8, we get that measurement. So 9 times 9 equals 8 times the diameter minus 8. So simplify. Solve for D. Okay, and we're talking about diameter, so we need to have units. So our answer is 18 1/8 inches. Again, you have two chords intersect inside the circle. So I can take this segment times this segment equal to this segment times this segment. And because this is the diameter, this segment is the diameter minus the measurement of that one. Okay? All right, let's move on. All right, a secant segment is a segment of a secant with at least one endpoint on the circle. Remember, a secant is a line that intersects 2 points on the circle. An external secant segment is a secant segment that lies in the exterior of the circle with one endpoint on the circle. Okay? So, we have segment PM is a secant segment. Intersects the circle right here, and it's a segment. We also have KM, and then also NM and JM. Now, NM and JM are external secant segments, okay? All right, so we have a theorem here with our secant segments. And what this saying is if two secants intersect in the exterior of a circle, here's your secants, they intersect exterior point E, then the secant times the exterior secant equals this secant times the exterior secant. And that's what you have right here. AE times BE equals CE times DE. So let's apply. So we've got two secants here. So I can take, all right. So I have, this is secant DE times 7. To get the 16, I have to take the 9 plus the 7, if you didn't see that. 9 plus the 7 to get this secant. And I put that equal to 8 plus x is your GE times the exterior secant. Simplify and solve for x. Once you find x, then you have to find the length of each secant segment. So here's one of your answers. And then ED is 16. And GE, or EG, is 14. All right, same thing. I'm going to be quiet and let you work this one on your own. If you get stuck, you can look up here at the board. All right, students, once you solve this one, because it says the length of each secant segment, it doesn't say to give your exterior secant segments, but it doesn't say just to give your secant segments. So let's go ahead and do the exterior also. So we have HG is our exterior secant segment, and that's 13. And we also have KG, which is 9. Okay, a tangent segment is a segment of a tangent with one endpoint on the circle. Segment AB and AC are tangent segments. Okay, so tangent with one endpoint on the circle, and they intersect exterior outside that circle. So we have a theorem to go with this one. All right, so secant AC Here's your secant because it intersects through the interior of the circle, and tangent DC. So if you take secant AC and times it by the exterior BC, you can put that equal to DC squared. Why? Well, if this were extended inside, it would be this times this. So let's apply this one. Okay, so you're taking ML, your secant segment, times your exterior secant segment, and putting it equal to the line of tangency, which is, or the segment of tangency, which is the KL squared. Substitute in, solve for x. X is going to give you plus or minus 10. Now, can we have a negative value for measurement? We cannot. So your answer is positive 10. All right, same thing. I'm going to be quiet. Once you solve this one on your own, if you get stuck, look up here at the board. Now, if you left your answer 51/7, I will also accept that. And that's it, guys. Got one more flip lesson after tonight's lesson, and y'all have a good one.